So now for our check for understanding. Does generic ice cream melt faster? So few people enjoy melted ice cream. I personally like mine a teensy bit melted, kind of soft and mushy, but okay. Being from the sunny state of Arizona, Megan and Jenna decided to test if generic vanilla ice cream melts faster than premium brand vanilla ice cream. At 25 randomly selected times during the day and night, the girls put a single scoop of each type of ice cream in the same location outside and waited for them to melt completely. Why should you use a one-sample T procedures to perform inference about a mean difference in this setting? Well, do we have a natural pairing? So we have 25 randomly selected times during the day and night, and they're putting a scoop of each type of ice cream, right? So we have a natural pairing between the time, so eat both ice creams. There is a natural pairing. Both types of ice cream are paired by time. And they experience the same temperature and the same time of day and the same location. So again, that's our natural pairing there, which is why we think a one sample T procedure, also a paired T test. Note, a one sample T procedure is also known as a paired T test. So we have the pairing of the data. Next question. A dot plot of the differences in time to melt completely, premium minus generic, is shown below. The mean difference is 1.32 minutes and the standard deviation is 1.14 minutes. So we've got this one and we've got this one, right? There we go. Explain why there's some evidence that premium brand vanilla ice cream takes longer to melt. Well, 15 of the 25 times, if we look at this, so right here, all of these is where there's a positive difference, okay? So premium took longer, minus generic is positive. Premium took longer to melt, all right? So that's our sum evidence right there, right here, 15 out of 25. So let me go ahead and write that, 15 out of 25. So I'll just put it right here. 15 of the 25 times have a positive value, which means premium takes longer to melt than generic, right? Now, do the data provide convincing evidence at the 0.05 significance level? So we got convincing evidence, alpha is 0.05, that the premium brand of ice cream takes longer to melt. So let me show you how we would set up this hypothesis test. First of all, our parameter is the mean difference. All right. So what is that? Let me go ahead and show you what it looks like. It's that mu. So that's a true value. So it's the true mean in the differences. All right. And our initial hypothesis is that there is no difference. Okay, so this difference, the true mean difference is 0. And, well, actually, let me go ahead and define my parameter first before I worry about hypotheses. I jumped ahead. Is the true mean difference in melt time, which is premium minus generic. Okay. Then we have our hypotheses. All right. So we have H naught, which is that this mean difference, let me go ahead and do that again, mean, and then I'm going to put my difference, is actually equal to 0. So that's our assumption, is that there is no difference, right? And our alternate, which is basically that mean difference is actually positive. This might also be called mu d. So if it's positive, it's greater than 0. And we're going to use significance level alpha, which looks like this. It's like an A equals 0.05. So it looks a lot like an A. It's not exactly like an A. All right. What method will we use? We will use a one sample t-test for the mean difference. So here we have, we're going to do the mean and of the, oops, I don't need an alpha, difference. All right, so that's what we're going to do our one sample t-test. We also have to check conditions. So the first condition is random. Did we get a random sample? If you look up here, 25 randomly selected times right there. So it is random. So I'll come back down here. 25 randomly selected times. All right. And then is it a normal, large normal sample? Well, it's only 25. So how do we get around that? Well, if the dot plot doesn't have any strong skew or outliers, and there's, I mean, you could say, oh, that looks like an outlier, but maybe that's okay. That's not no obvious outliers. So there is no strong skew or obvious outliers. So this condition is met. All right. And this condition is met. All right. Because we did randomly sample it. Okay. Then finally, 10% condition. Since we sampled, we definitely have sampled. 25 is less than 10% of all possible times a day. In fact, there are probably quite a few. If you do it by minute, you got 60 minutes in an hour, 24 hours. So over 1,200 that you could think of. 25 is definitely less than that. And if you wanted to go by seconds even, you could get more fancy. Okay, so how will we do this with technology? So we know that we have our mean and we have our standard deviation. Let's see, right here. So I will go to the Statlet. Oh, looks like I don't. Here we go. One quantitative variable. And I'm going to click mean and standard deviation. My mean time is Oh, what time is it? Let's look. I don't have it so easy. 1.32 minutes. 1.32 minutes. All right. Standard deviation is 1.14 minutes, and we had 25 times. We begin our analysis, and this is difference in melt times. So the difference is captured already in the data. We don't have to do it later. So we hit begin analysis, and what we're going to do, we can do a t-interval. In this case, they say convincing evidence. I'll go ahead and do the t-interval just for the fun of it. And you can see that it's always positive. So it seems that we're very confident, 95% confident, that the difference in the two for sure is somewhere between 0.8494 and 1.796 minutes. But I could also do a one sample t-test, which is typically what you're dealing with when they ask you for convincing evidence. Our hypothesized mean is that there is no difference. And you can see there is your p-value and your test statistic. All right, so let me go ahead and copy that down. So if I run a enter data in one Statlet, or enter statistics, I should say, in Statlet in one quantitative variable. All right, so what did that look like? Let me go ahead and go back to it. So basically what we did is we just entered our data right here with one quantitative variable, single group, and all that information. So let me go ahead and copy that down just so you can see it down here. So this is basically what we did, right? And you can see there's our test value and our test statistic. Okay, now just to show you what that looks like in the distribution, if we were to do let me go to Statlet again. I do have the test statistic, which is 5.79, I believe. Let me look. 5.79 is good enough. So we're going to go back to the Stapplet as soon as it loads. And I'm going to show you what this looks like graphically on the t-distribution. So we're going to t-distributions. We have 25 data points. So I'm going to put degrees of freedom as 25 minus 1, which is 24. And I want to the right of a value, and our mean on our sample was 1.32 minutes. All right, and we calculate our area. And so basically, this is a t-distribution, right? Selected area. Voila, that is our probability of getting this result. So our area is 0.099. Oh, let me make sure I have the right test statistic. Oh, I have the wrong test statistic. Bad. 5.79. Let's go back to my t-distribution and put 5.79. I don't know where I got 1.32. There we go. Oh my goodness, the area is almost 0. So it is 0 as far as this is concerned. We'll copy that and put that in our thing. So let me throw this one away. This is what we're calculating, a super tiny area. So we basically got a p-value of 0, which is also what the Stapplet was saying, right? And what is our conclusion? Because our p-value, it's less than alpha of 0.05, we reject H0. We have convincing evidence that premium ice cream takes longer to melt. And we're done.